Hi everyone, let us discuss Cauchy's mean value theorem. Okay, so in Cauchy's mean value theorem, we have two functions f and g. Both are defined on closed interval ab, right? F and g are defined from ab to r, such that f and g both of them are continuous on closed interval ab. F and g both of them are differentiable on open interval ab. Third condition is f dash of x must be non-zero for all x belongs to open interval ab. In that case, this theorem says there exists some point c lies in open interval ab such that g dash of c upon f dash of c is equal to g of b minus g of a. That means g of end point of that interval minus g of first point of that interval upon same f of b minus f of a. So now we are going to prove this result. Okay. So before that we will prove one thing. Okay. So let me write it here what we are going to prove. Okay, I am going to write here. First we will prove that f of a is not equal to f of b. This is a very important thing. See, why it is very important? Because if f of a and f of b both of them are equal, we will have 0 at denominator. So first of all we need to prove it will not be possible. We are going to prove that f of a is not equal to f of b. But in mathematics, when we want to prove anything, most of the times what we do, we assume exactly opposite to that. So here also I will do the same. So let it possible, let us see what will happen if both of them are equal. Let it possible f of a is equal to f of b. Suppose both of them are equal, see what will happen. See what we have, f is continuous, right, on closed interval ab. F is differentiable on open interval ab, as well as f of a is equal to f of b. Do you think it is already we have seen somewhere? Yes, these are conditions of Rolle's mean value theorem. So therefore, if f of a is equal to f of b, we can say f satisfies all conditions of Rolle's mean value theorem. Okay, so I will write. So then f satisfies all conditions of Rolle's mean value theorem. All conditions of Rolle's mean value theorem. So therefore, by Rolle's mean value theorem, we can write there exists some point c belongs to open interval ab such that, yeah, can you tell me? By Rolle's mean value theorem, what can we write? There exists c belongs to open interval ab such that f dash of c is equal to 0. Tell me, will it be possible? By Rolle's mean value theorem, definitely it will be possible, but in this theorem, they have given this condition that f dash of x will be never 0. It will never 0, getting? And here we are getting is equal to 0. So we get a contradiction here. We get a big contradiction here. Why we are getting contradiction? Because our assumption is wrong. So what is our assumption? Therefore, our assumption is wrong. So our assumption was f of a is equal to f of b. So that is wrong. That means f of a is say f of a is equal to f of b. That was our assumption. That is wrong. Therefore, f of a is not equal to f of b. So initially we proved that yes, f of a and f of b cannot be equal. So now let us start the actual proof. Now we will prove it using one construction. We are going to define one function on our own. So let me write here. We are defining a function phi from closed interval ab to r as phi of x is equal to g of x plus a f of x. Did you notice we define a function phi with the help of f and g, which we already have two functions. Okay, so we simply use those functions here. There is no more space to write. Make a screenshot of it first, then we will go further. Okay, so let us continue now. See, this function we have defined phi. So let us use the given information. What we have, let me write here. We have, okay, just I need to add one thing. See, here we have taken a constant a. A is any constant, but it should satisfy one condition. Let me mention here, where a is a constant such that phi of A is equal to phi of B. Getting? So you can take constant A, but it should satisfy this condition that phi of A should be same as phi of B. Let us work on this condition and let us see what will we have. So consider, I am considering this condition phi of A, and I will simplify it, phi of B. What is phi of A? Simply replace x by A, you will have phi of A. So it is g of A plus AF of A. Phi of B, that means replace x by B right here. So you will have g of B plus A f of B. We want the value of A now. Okay, so what will I do? I will take all terms of A on one side and the terms without A on another side. So yes, I will keep it here, A f of A. I am shifting that A f of B on this side. So minus A f of B is equal to g of B, right? G of A I am shifting there, it will have minus sign, g of A. I can take A common, but see, I will take minus A common here. So if you take minus A common, it will have plus sign then, and it has already plus sign, so we are taking minus common, so I should write minus sign here. This is equal to g of B minus g of A. So therefore minus A is equal to g of B minus g of A divided by f of B minus f of A. So this is value of minus A. This is a very important thing for us. Okay, so let me call it as equation number 1 and I will highlight it. So this is equation number 1. Okay, equation number 1. So now let us go further. We have, I am going to use the given information. We have f and g are continuous on closed interval AB. This is a given thing. F and G, both of them are continuous on closed interval AB. But see, our phi is defined with the help of F and G. If F and G, both of them are continuous, then phi is also continuous. So implies phi is continuous on closed interval AB, right? And the second information is F and G are differentiable on open interval AB, right? See, phi is defined with the help of F and G. F and G are differentiable, then obviously phi is also differentiable. So implies phi is differentiable on open interval AB. And see, one more condition we have, that is phi of A is equal to phi of B. This thing also we have assumed. So let me write phi of A is equal to phi of B. See, phi is continuous, phi is differentiable, phi of A is equal to phi of B. So all these are conditions of Rolle's mean value theorem. Therefore, we can say phi satisfies all conditions of Rolle's mean value theorem. So therefore, by Rolle's mean value theorem, Rolle's mean value theorem. Okay, so let me remove this part, then we will continue. Okay. So what can I write by Rolle's mean value theorem? There exists C belongs to open interval AB such that phi dash of C is equal to 0, right? Simply I use Rolle's mean value theorem here. But what is phi dash? Okay, so let me write here. But what is our phi of x? Our phi of x is equal to g of x plus f of x. This is our phi of x. Okay, I am calling it as equation number 2. Phi dash of x, its derivative. Addition is there, you can take separate derivative. Derivative of g is g dash of x, a constant derivative of f is f dash of x. What we want? We want f dash of c. So simply replace x by c, you will have f dash of c. So g dash of c plus a f dash of c. Let me write here. So from 2 it is g dash of c plus a f dash of c is equal to 0. Okay, I am putting here. Let us take a f dash of c on that side. So you will have g dash of c is equal to minus a f dash of c. So now I want some more space to write. We don't have that thing. So make a screenshot of it. Then I will go further. So let us continue. See, purposely I have kept this equation number 1 here. We are going to use it now. So that's why. Let us continue here. We have g dash of c is equal to minus f dash of c. Let us shift f dash of c on left hand side. It will be in denominator. G dash of c upon f dash of c is equal to minus a. But see, equation number 1 gives the value of minus a, so let me put it here. So therefore, g dash of c upon f dash of c, my value of minus a is g of b minus g of a divided by f of b minus f of a. Let me mention here from 1. Okay, from 1. Yes, in this way we proved same thing we want, right? So hence the theorem. Let me mention hence the theorem. That's it. In this way we proved this theorem. Okay, make a screenshot of it, then we will stop. Thank you. Bye bye.